Okay, so number one, and if I can fit everything on this paper, you should be able to fit enough stuff on your paper. So, number one is dy dx equals x parentheses y minus 1 over 4. And it says to find the particular solution. And they specifically tell you that f of 1 is equal to 3 on problem number 1. This one is worth 9 points, just like that on the AP test. They want you to go back to find the particular solution, which means that this is the derivative. They want you to go back to f of 1 equals 3, or they want you to get back to f of x. Or the same thing as f of x is the same thing as y in math, right? So they give you the derivative. They want you to go back to the original, which is y. So we are going to do the antiderivative in this problem, right? If they give you the derivative, it's 50-50, you guys. That's all you've got on this AP test. If they give you the derivative, you have to integrate. If they give you the integration, you find the derivative. There's really only, you either integrate or find the derivative. Once in a while they'll ask you to find the double derivative, but that's not as common as integrating and derivative. So let's just do this problem really quick. This was chapter 7, sorry. Do you guys remember that you have to separate the variables? Do you guys remember doing this? So I'm going to bring the y minus 1 over to this side by dividing, and I'm going to leave the x divided by 4 on this side. So I separated the variables. The 4 could have came over to join the y minus 1. The 4 is just a constant, so it could go on either side of the equation, right? I ended up putting it here, and then I put the rest of the problem to the right because there's not a lot of room to do this. So I'm going to start it here, and when I run out of room, I'm going to put it over here. And then once you separate the y's and the x's, so I brought the y minus 1 over here with the dy. I left the x over 4, but I still need to bring the dx over here. I forgot to do that. I'm going to integrate, and I'm going to integrate, if you guys remember this. This is easy on this side because this is just to the first power, so you're going to add 1 to that, which is x to the second. And you're going to end up dividing by 2, which ends up being x squared over 8 with a plus c at the end of it, correct? How do I know I did it right? What's the derivative of that? Take the 2, put it out in front, change that to a 1, and 2/8 is the same thing as 1/4, so I know I did it right. This is the same thing as y minus 1 raised to the negative 1 power, correct? So when you add 1 to that, that makes 0, which is the natural log of y minus 1. They give you this up here because you have to find your c value in this problem. When x is 1, y is 3. When x is 1, y is 3. Natural log of 2. Because 3 take away 1 is 2, right? And then doesn't c equals natural log of 2 minus 1/8. And then you're almost done. I'm going to go over here. It's the natural log of y minus 1 equals x squared over 8 plus c equals all of this, the natural log of 2 minus 1/8. All of this is your c value, correct? And then they want you to end with y by itself. So there's a little imaginary e right there, right? So I'm going to take e, raise it to all of this, e raised to all of this equals y minus 1. So if I just stick a plus 1 in the front of this, and erase the negative one after that, I am done with my problem. I got y alone, and that's all they want in number one, all they want in number one, 9 points later. Yeah, you see how I got the one, I just brought it over to the other side, so. Can you do that on your own? Hopefully you can do that one on your own. So, okay, we have 23 of these to do. I want to get done with all of these. I want to get through all 23 of these by the end of the hour. So, number 2. Equation of the tangent line. That's the most popular thing we did this year. The equation of a tangent line is y minus y equals mx minus x. That's all you need to write for number 2. The equation of the tangent line, y minus y equals mx minus x. This is the tangent line. What's the normal line? Yeah. If they're not going to ask you to find the tangent line, they'll ask you for the normal line. If they don't ask you for the equation of the tangent line and they ask you for the linearization, remember linearization, which we learned in like chapter 7, is the same thing as the tangent line, just another name. If they ask you to do linearization, there's the word what in it? Line. And you should know, wait a second, that just has the word line in it. I bet you just do y minus y equals mx minus x. So that's it for number 2. Some of these are actual problems that we're going to do, and some of these we're just going to talk about the concepts to bring back things. So maybe we should have done this before with multiple choice, but I think this was a good spot to do this in. Number 3, find the area of a region. I'm just going to make this, and I'm going to make this f of x, and I'm going to just make this, which is g of x. And they want you to find the area of that region. Find the area of any region. You need to integrate from some x to some x value, right? And wouldn't you have to figure out where they intersected? From A to B. And isn't it top minus bottom to figure out the area of a shaded area? Isn't the top f of x in this problem minus the bottom g of x? Don't ever forget, whenever you're setting up an integration rule, don't ever forget the d of x at the end. Don't ever forget d of x or d of y. And that's it for number 3. So some of these are not working out. Some of these are just quick little remembering things. So number 4, definitely you're going to have one like this on the test. This will be a free response question. They're going to give you a chart, and they're going to give you 2, 4, 6, and maybe a 10, and maybe a 2, 1, 3, and 4, something like that. And there, you have to look at the chart and do an LRAM. By looking at that quick little chart, you have to do an LRAM, which stands for left rectangular approximation method, right? Left rectangular. When you see R, rectangular is width times length, right? Rectangular is width times length. The widths are your x values, and in between, the width for this one is 2. The width for this one is 2, but the width for the last one is 4. If they're all 2, 2, 2, 2, you could have put 2 on the outside. You guys remember putting just the width on the outside? But this one, they're not all the same, so you have to break it up into width times length. And then if you're doing the left Riemann sum, you have to, one of these four numbers will not be used because you're going from the left side, and if you're going from the left side, you're going to use the 2, the 1, and the 3, right? If you're going from the right side, you're going to use 4, 3, and 1. So it depends on which way you go. And I don't even know, what does that make? 4 plus 2 is 6, and 6 plus 12 is 18. If you did the left RAM. You could do the right RAM. You could also do, they might just ask you, I'm not going to even worry about it. We won't worry about it. Number 5. If they ask you to do the trapezoidal method, it's not width times length. The trapezoidal method is 1/2 height, base 1 plus base 2 is the trapezoidal method. You guys remember that? Yeah. And looking at the chart up above in number 4, there's going to be a 1/2. And again, you have to break this up because now instead of the widths up here, these are not the widths, these are the heights, and the heights have changed. It's 2, 2, and 4. So you're going to have a 2, 2, and a 4. And then the base 1 for the first one is 2 plus 1. For the second one, it's 1 plus 3. And for the third one, it's 3 plus 4. So the 2 only gets used once, and the 4 only gets used once, but the 1 and the 3 gets used what? Twice, right? Which makes sense. Then it goes 1, 2, 2, 2, 2, 1. So. And I'm not going to tell you what that is. Oh, I got it. It's 21. I didn't know I had it. 21 is the answer. Did I do something wrong?
No, I'm just making sure I understand.
These are the heights.
Yep.
And these are the widths, depending on if you use this or this. And these are your bases or these are your lengths, depending on which one they ask you to do on the AP test. Good? Okay, next one. Ooh, I like number 6. This is a tricky one. They're going to try to trick you. Number 6. Given Sally's rate. You don't have to write this, but given Sally's rate, GT is equal to, I'm just going to come up with something. 2x squared plus 3. Given Sally's rate, GT is equal to 2x squared plus 3. If you want to put 2x squared plus 3 in there, fine. Find the distance traveled. Find the total distance traveled. Isn't total distance traveled means to integrate? Yeah, an absolute value, yes. It means to integrate when they ask you to find the total distance traveled, right? It's tricky. This really, it says Sally's rate is GT. This is really the derivative formula. Even though it starts with GT, it says rate in front of it, and rate means derivative, doesn't it? So it looks like it's the original problem, but that's really the derivative. So you have to, you need to integrate this. And I don't know. I know that 3 is 3x. And if you add 3 to that, you get 2/3 x cubed. And then they would have to tell you from where to where, but I don't have anything to tell you from where to where. But would you have known that that was the derivative, even though they said just GT there? The rate in front of it means that it's the derivative equation. So you have to know that. They're going to try to trick you. Number 7, very similar. Maybe make a quick little picture of number 7. This is A, this is B, and this is C. And if they ask you in number 7 to find total distance traveled, you would have to add the A plus the absolute value of B plus the C, right? The negative part is really positive. And they tell you what the numbers were, like A is 1, maybe A is 1, C is also 1, but B is, let's say B is 8. They're going to try to trick you. This is not really 8, it's really a negative 8 or whatever, so. If they don't say find the total distance traveled and they ask you to find the area instead, you guys, then this is 1, this is a negative 8, and this is a positive 1, right? If they ask you to find just area and not total distance traveled, and this answer would be 1 plus 8 plus 1. This answer would be 10, and this answer would be negative 6. Total distance traveled is 10, area would be a negative 6, depending on what they ask you on the test, right? You have to know that total distance traveled, the negative part is always positive. Area, positives and negatives on the AP test. It's almost 2 already, and we're already on number 8, and I want to get to 24, so we're already a third done. That's how fast I'm doing this, because I'm just going over some important terms that we've learned throughout the year. And number 8, there isn't much to number 8. All they're talking about is what does this mean? Most of you know that stands for the double derivative. Double derivative. It also stands for acceleration, right? Double derivative acceleration. It also talks about, if they ask you about point of inflection, that deals with the double derivative. If they talk about concavity of something, points of inflection and concavity on a sign chart deal with the double derivative. So all those words you would have to find the double derivative on. And then while you guys are done with 8, I'm just going to draw the quick little picture on number 9. I'm just going to kind of draw it fast. Something like that is number 9. Number 9, they ask you to check the critical points. They're going to ask you to find the critical points. Boy, it really makes a difference, you guys, if this is f of x or is this f prime of x, right? It makes a gigantic difference which graph it is. You have to know what kind of graph this is. Let's just do f of x first of all. Let's just pretend that this graph is f of x, and I'm just going to explain this, but isn't this a minimum right down here? If this is the original graph, this is a minimum. This is a maximum on the original graph. This is also a minimum, and this is also a maximum, right? On a f of x graph. They're all the same. I wish one was higher than the other, because then you'd have a relative min and a relative max and an absolute min, absolute max. So if I change the picture a little bit, so it looks more like this, make this even longer. You have an absolute max here, right? You have an absolute min here. You have a relative min here and a relative max here. You see the difference, you guys? Absolute min, absolute max, relative min, relative max. That's on an f of x graph. But let's say this isn't an f of x graph. Let's say that this is, it looks something like this. Let's say that isn't an f of x graph. Let's say if it's f prime of x graph instead. This part, I'm going to change the color. This part here is above the x-axis, that means there's positive slopes, that means there's positive slopes, that means these are all negative slopes down here. If this is the derivative graph, if you go from a negative to a positive, isn't there a min right there when you go from a negative to a positive? You go from a negative to a positive, you have a min. When you go from a positive to a negative, you have a max. You have a min here, you have a max here, and you have a min here because you went from a negative to a positive. So it all depends on which type of graph it is. You're going to get it completely wrong if you don't know which one it is. If it's f of x or f prime of x, they're not going to ask you, they might ask you about a double derivative graph, but usually it's just a single derivative graph. You also have to check the endpoints on a derivative graph, you guys. Left is less, you have a max. If left endpoint is less, isn't that less? Then that point right there would be a max on the original graph. And if you don't like this, you could draw the original graph. That means the graph is decreasing to there, and then it's going to increase, you know what I mean? The negative means decrease, the positive means increase. So number 9 is just loaded with, depending on if it's an f prime of x graph or if f of x graph. But down below I told you it was a derivative graph. So they have to tell you what kind of graph it is. Because if you think that that's f of x, you're going to name the maximums and minimums completely wrong. That's really important. So number 9 is a really important question. Okay, moving on. Number 10, find the speed of something. Whenever they ask you to find the speed of something, it's the absolute value of velocity, right? That's all you have to write for speed. It's the absolute value of velocity. That's all you have to remember. You find the velocity and take the absolute value of it. Number 11, just go kind of quick here. Find the particle's position at t equals 4 if the initial position is f of 0 equals 7. You have to integrate from 0 to 4 some derivative, and you're going to get some value, but if you forget to add 7 to the end of the problem, you're not going to get the right answer. Don't forget to put the initial value as part of your answer. This was chapter 8, you guys. Do you guys remember that? When you have to add that extra. If you forget the f of 0 equals 7, of course, if this is a multiple choice question, this will be one of the answers, and adding 7 will be another answer. And they're going to try to trick you if you don't read the fine print. Number 12. Water flows in a tank at the rate of g of x, and it flows out at h of x. It has 300 gallons of water to begin with. How much water will be in the tank at t equals 3? This is the exact problem from the AP test. So really quick. Water flows into the tank at the rate of g of x. It flows out at h of x. It has 300 gallons to begin with. How much water will be in the tank at t equals 3? Well, first of all, the initial started with the 300 plus. That's just like this number 7 right here. You have to have 300 in your problem. So you need 300. The rate at which its water flows in from 0 to 3 is g of x. And it flows out, which would make it a negative, right? Wouldn't it go a negative? It's flowing out. 0 to 3 f of x. And that would be the answer depending on, you have to start with 300 because that's what you started with. It flows in here, flows out here. They'll give you these functions and you would have to integrate. So that's what it would look like. Flowing in is a positive integration. Flowing out would be a negative integration.
So because it says rate, that means it's already in the...
It's already,
yeah.
that's already the derivative. This is the
So then
derivative.
they integrate to get it back to the...
Yeah. Yeah, and then how much water will be in the tank? How much water, finding area, total distance, all that means to integrate in math. Yeah. Oh, here we go again. Given the graph of f prime of x, you can find the area. Oh yeah. Okay, so here's 13 really quick. This little wonderful picture again looks like this. And they tell you that this is the derivative. and they want you to integrate. Let's say they want you to integrate from a -3 to 0. They want you to change it from a -3 to 0. If you integrate from a -3 to 0, and you draw a line up here, isn't this a triangle? Isn't this a triangle? So can't you find the area using geometry? Whenever you integrate, you're finding the area, right, or total distance traveled, but we don't have an equation for this problem, but we can use geometry to come up with the answer. This is gonna be a negative area, this is gonna be a positive area, right? Something's wrong with this integration though. No, that's right. Smaller number first, bigger number, higher less, that's fine. So we're good with that. Do you see that smaller number's always on the bottom, bigger number's on the top? So remember that you can always rely on geometry to find the area if they don't give you an equation, right? And we learned how to do area, so. What do I have for 14? Anything? I don't even have 14. Let h of x be the antiderivative of that. H of 5 is equal to pi, find h of 2. H of 5 is equal to pi. Let h of x be the antiderivative of that. I don't even know where I got that from. We're okay, we're done with 14. I don't even know where I came with that one. I think I must have found that someplace, but move on. 15. If they ask you a number 15 to find the max or the min, you guys, you take the derivative, set it equal to 0, right? To find the min or the max, right? And then you would make a what chart? If they ask you on the AP test to find the min or the max, you have to find the derivative of it, set it equal to 0, set that and find out, make your sign chart where it goes from positive to negative or negative to positive, it's min or max. And that's it, we're on the 3rd page. Finding concavity in number 16, same thing. Instead of, yeah, exactly. Number 16, double derivative, set it equal to 0 and make a sign chart. That's all you have to do. Number 16, if they ask about concavity, find the double derivative, set it equal to 0 and make a sign chart. Oh, I like 17. What is the average rate of change? Put down average rate of change instead of writing it out, equals slope. If they ask you to find the average rate of change, all you are doing is finding the slope. It's just another name for slope in math. And obviously we hope you guys know it's this. Y minus y over x minus x. Number 18, find the average value. You're integrating from a to b, some f of x dx. But don't forget to do the 1 over b minus a, which would give you the average. Do you guys remember that formula? The average rate of, you don't remember this one? No. I don't have the mean value one on here though. Yeah, non-differentiable. If 19, if it says it's a non-differentiable, it means you can't find the derivative. Like this, you guys. At 2, this is the non-differentiable at 2 because there's a corner right there. You can't find the derivative. That's what non-differentiable means. If it says differentiable, it means you can find the derivative, right? Go down to 23. What does it mean to find the position of something? It means to integrate. So number 23, what does it mean to find the position? It means to integrate. 22, what does it mean if it says f of x is twice differentiable? So I'm going to work my way back up to 21, which is the long one. Or 20 and 21 are long, but 20 takes a while, so. Number 22, if it says f of x, you can read it. F of x is a twice differential function. All it means is, it means that that you can find the derivative of it, and you can find the double derivative of it, right? It's a what does it mean? It says that f of x is a twice differential function. That means you can keep going. It can't be this though, you guys. If y equals 3, y prime equals 0, y double prime also equals, that's not really twice differentiable because you ran out, right? This is twice differentiable because you can keep going. It might even be 3 differentiables, 4 differentiables, but at least it's twice differentiable. That means you can find the min and the max, and that means you can find the concavity because it's twice differentiable. You know what I mean? This wouldn't be too good to find the concavity though. So 21 and then 20 and we are done. 21, f of x is equal to 0 to x g of x dx, and then they say f of 3. What does that mean really quick? And then we're done. We have one more problem after this. Basically, f of x is equal to this, and they want you to find f of 3. You're going to replace the x with a 3. That means you're going to replace this x with a 3. And then they're going to probably give you this, and you'll have to integrate this function from 0 to 3 to bring you back to the original, right? Does everybody understand that? That you would have to integrate this to bring you back to the position. Do we understand that? Because you're trying, this is the derivative, and this must be the position then. And they want you to integrate from 0 to 3 to bring you back to the position. And then the last problem is number 20. Last problem. H of x equals f of x over x squared plus 1, h prime of 1 equals what? And I don't know why, but I just wanted to go over this one with you, and then that is it. I'm just trying to, I'm trying to figure out if that's enough information. Oh, yeah, I didn't give you enough information. Given f of 1 equals 3 and f prime of 1 equals 2 is what's given. So if you saw this on the AP test, and this was a free response question, and they give you 8, how did that do that? They give you h of x is equal to f of x all over x squared plus 1, and they want you to find the derivative, correct? So you're going to do low times the derivative of the high minus high times the derivative of the low all over, what is low squared? X squared plus 1 squared. H prime of x would equal that. If h of x is equal to this, h prime of x would equal that. Does everybody see that? That would be the derivative, low d high minus high d low all over low squared. And then if f of 1 is equal to 3 and f prime of x, so f prime, and you're trying to do 1, so you're going to do f prime of 1 goes there. You're going to do f of 1 goes there. You're going to go, what is it? 2 of 1 is going to go there. You're going to put a 1 there, and you're going to put a 1 there. Because how do you know that x is always going to be 1? Because they're trying to find h prime of 1, right? So all of your x's are going to end up being a 1. And you are going to get 1 plus 1 equals 2, and 2 squared on the bottom is 4. 1 plus 1 is 2. F prime of 1, what's f prime of 1, you guys? Doesn't that equal 2? minus f of 1. F of 1 equals 3 times 2. 4 take away 6. 4 take away 6 is a negative 2/4, negative 1/2. And that's it. We are done with time to spare. Did you follow all that?
Yeah.
Like 90% of it.
That's good.
I'll take it.
90%.